So like I said, I'm here today to talk to you about a beginner's guide to spatial SQL. So for those of you who I don't already know, my name is Helen McKenzie, and I'm a geospatial advocate at CARTO, which is probably a job title that you haven't really heard too much. But basically, it's kind of like a technical marketing role at CARTO. So we say I'm like CARTO's hype woman. I basically go out within the geospatial community, but also within other industries, and basically hype CARTO, hype location intelligence. I'm guessing from the people on the call, you're all already super into geospatial, so I don't really have my work cut out today. So thank you for making my life easy. So yeah, over the next sort of 45 minutes, half hour, we're going to cover the following things. First of all, I'm just going to give you a bit of an introduction to who and or what CARTO is. I'm aware it's not something that many people here have probably used or are that familiar with. Then I'm going to talk to you about the benefits of SQL and why it's something you should consider bringing into your workflow. Then we're going to go through some of the basics, and I'll give you a bit of a demo and show you how you can get started. And then we'll go on to something more advanced, and I'll show you some of the more advanced analytics. So let's get going. So first of all, who's CARTO? This is CARTO. This is us on our annual trip to Spain. We're a Spanish-based company, so most of our team are based over in Spain. You can see me, I'm the really, really pale one amongst all the beautiful Spanish people, lathered with SPF 50 sun cream because I do not stand the Spanish heat well. But our mission is basically we want to empower our customers with the very best geospatial tools and data. And we're quite a small company, but we like to think we're quite mighty. We think for our size, we accomplish quite a lot. And I always describe us as free t-shirt city because as you can see here, we're all wearing the same t-shirt. And I feel like since I've been at CARTO, which is about 6 months, I've gained about 8 CARTO branded t-shirts. So if you like a free t-shirt, consider joining CARTO. And as I mentioned, we're a Spanish team, so we eat so much tapas, which is amazing, but not great for my waistline. So a bit more about what CARTO does technically rather than what we eat, even though that is a big part of us. We sort of position ourselves as a location intelligence platform. So in contrast to platforms like Tableau and Power BI, which are business intelligence platforms, where you can basically just drop points on a map and say, where are things? We like to take that a step further. We like to think about why are things happening. So the sort of contrast there is with a business intelligence platform, you can say where are tourists staying and going to. But with a location intelligence platform like CARTO, you can model the patterns and movements of tourists to improve operational efficiencies. So we really position ourselves at the sort of data science end of the geospatial industry. So what we actually provide people is sort of 3 main things. So first of all, it's our platform, which our sort of USP is that we're a cloud native platform. So we can plug into all of your cloud native data warehouses, things like Google BigQuery and Snowflake and Databricks and all of these things to just make your work that much faster and easier if you're using cloud native data. And then we have, so as part of that, we have our CARTO Builder platform, which I'll show you in a second. Secondly, we have our spatial data catalog, which is about 11,000 data sets. And when I first joined CARTO, I could not believe the data that's on there. It's amazing. I'll show you a bit more in a second. And then finally, services. So if organizations don't have the skills or resources in-house to develop their own apps and analytics, then we can help people do that. So this is just, I'll skim through this quite quickly, but this is just a slide of some of the organizations that we work with. So BBC, IKEA, Decathlon, a real range of organizations. I'd say the majority of our customers are probably retail and logistics and consumer packaged goods, CPG companies, but we really do work with a really wide range of companies. So just to illustrate what CARTO actually is beyond just me talking. There's a few different elements that you get as a CARTO customer. The first one is CARTO Builder, which is our visualization analytics suite. So it's a browser-based platform, so you don't have to download any software, and you can do all of this visualization from your browser. So interactive visualization elements, dynamic widgets, you can share these publicly and privately, and you can also do all of your SQL-based analytics, which I'll be talking about in a bit, in-app. As I just mentioned here, so you can do all your querying from the app, which is what this looks like, and that has immediate effect on your visualization. So you don't have to sort of do your analysis in your GIS platform and then upload it onto your web mapping and then be like, oh no, I just need to change a parameter and go through all of that again. You can do all of that from the app. And then I think something that could be quite exciting for a lot of people here is our Data Observatory. So we have about 11,000 data sets on a range of different topics, which I'll go through in a second. 99 of those data sets have global coverage, and the geospatial joke I always make is that includes Greenland. So we know that Greenland is always the grey, no data part of a map. We actually have data on Greenland, which is pretty exciting. So these are the types of data sets that we have for people. So we've got financial data from organizations like MasterCard, so you can bring in where people are spending different amounts, where they're coming from, where they're spending it, what they're spending it on. We've got human mobility data, so things like where are highest footfalls, where are people traveling from and spending their time, road traffic data, demographics, loads of different things. If you've got a spare 5 minutes, Google CARTO Spatial Data Catalog. There's a public facing version, and you can just look through all of this, and there's a lot in there. And then finally, we have our analytics toolbox. So these are some of the things that we're going to be going through in a little bit. They're SQL-based user-defined functions, so people can do analysis directly within CARTO. And yeah, I won't go too much into that, so we can go through it a bit later. So next, let's talk about the benefits of spatial SQL. So I'm afraid I've built in some audience participation into this, but don't worry, it's all anonymous. If you are so inclined, it would be great if you could go over to slido.com and type in this room code, which is 5338874, and you'll see a question that says, what is SQL used for? And I'd just love to hear from some of the people here about what they think SQL is used for, not just in geospatial, but on a sort of wider level. What's your sort of opinion of how people are using it? It's totally anonymous. You can say a word, say a sentence. I'll give it sort of 30 seconds or so. Yeah, it'd be great to hear. I should have put some hold music on everything, 3 exclamation marks. I love it. Well, you can't be wrong then, can you? That's there are no wrong answers. Querying data, absolutely. So SQL actually stands for structured query language. So you're basically running queries and querying data sets. You're absolutely right. Searching databases, yeah, 100%. It's an amazing database management tool. Programming, managing data, 100%. I'll give it a couple more seconds. Map Publisher, you found out? Yeah, absolutely. So anyone who's in Claire's workshop earlier would have seen that Claire was actually using some SQL without realizing it. Querying structured data, absolutely. Filtering, querying, yeah, this is all 100% hitting it on the mark. But I think there's something that a lot of people don't necessarily know that SQL will be used for, is actually analysis of data. It's not just about saying, here's my data set, let's extract some bits from this data set. You can also run all sorts of analysis, like to use sort of typical GIS language, you can run dissolves, you can run buffers, you can do spatial joins, you can do network analysis, loads of things. Yeah, this is all amazing. Thank you all so much. I'm going to move on, but all of this is 100% right, and so much more. So this is my favorite benefit of spatial SQL, and I've got Meryl to help me out here in emphasizing how important it is. So if you work in geospatial, you probably hear the word single source of truth mentioned all the time. And what that means is being confident that everyone analyzing or mapping with a data set is working from the exact same data set. If there are multiple versions of that data set, then someone could make some edits to that data set. One of the data sets could be outdated, and then suddenly you have 2 sources of the truth. And what that could mean is your report is wrong, or there's 2 different figures on the same thing in that report. I think my favorite example of this once was at the company I worked at before I joined CARTO. 2 people downloaded a shapefile from a SQL database. They both edited it on their local machines, and then they both called me and asked me why the data sets were different. And it's because they had 2 versions of the truth, and 3 if you count the SQL database. So what is great about SQL is it means that you can query one data set and get something kind of different from it without having to create a copy of it. So you get that single source of truth. So I think for a lot of people here, the best use of SQL is basically if you have a really massive data set, like so for the UK, a NAPTAN data set or a code point postcode data set. Those have tens of thousands, if not hundreds of thousands, if not millions of records in them. And often if you're using something like Map Publisher or QGIS, often you might want to download and create a copy of that data set that just contains the data that you're interested in. So that might be just data of one classification or just data for London or something. But then you immediately have 2 versions of the truth. So if you're using SQL to just query that data rather than create a copy, you're still using the same data as everyone else in the company. And that is absolutely invaluable. And there's actually probably a lot of people working for companies here who are trying to conform to ISO standards where this is really important to that. So you can work with SQL-enabled databases when using Spatial SQL, but you can also use this, and I'll show you more about this in a second. You can also use SQL workflows to better manage and analyze more traditional geospatial formats, so CSVs and shapefiles. What's great about it is it supports collaborations between teams. So SQL is a language that not just geospatial analysts use, business analysts use it. You might have people who are doing sort of strategy planning in your company, or HR might be using SQL. And it means that you can better collaborate with those teams because everyone can sort of speak that language. Like with a lot of programming, there's more opportunities for repeatability and automation, which just speeds things up so much, just makes things so much easier. You don't have to go back and run every section of your analysis if you just wanted to change a number at the first section of analysis. Reduce data storage redundancy. So this is something that before I sort of learned about SQL, something that really made my life difficult was if I was running a workflow that, say, had 4 different analysis steps. In each step, I'd be generating a shapefile or a CSV that I didn't need. I just needed the end result. So running something like SQL or other programming languages means you're not generating those, I call them dump data sets. I think I just made that up. I don't know if that's a real phrase, but you're not generating those. You just have that important end result. So you're not having to store all this irrelevant data. It's also so fast, and you'll see some examples of this later. Like SQL queries, particularly for SQL enabled and particularly for cloud databases, are incredibly fast. And as coding goes, it's actually really straightforward. I think something that puts a lot of people off coding is that it looks really hard and really difficult to use, and there's a really steep learning curve. And something that I personally find is when I start learning some coding, immediately, if I want to do anything, there's so many other things I want to learn. Whereas with SQL, it's very logical, it's very intuitive, and also you can get really far with just the basics. You don't have to immediately be installing loads of packages and learning 20 different things. So that's my 2 cents on why SQL is great. But why aren't mappers using SQL more? So I think there's sometimes a misunderstanding of what it's for, and that's why I asked that question at the start. Quite a lot of people said that it's about managing data, and it absolutely is, but there's so much more you can do with it. And the main reason I use it is for geospatial analysis. I think there's a misunderstanding that you need to download specialized software and specialized tools to be able to use SQL. And I think the next slide potentially shows you that that's not the case. And as I mentioned earlier, program is really hard, but I think what makes it harder if you don't do any when you first get into it is that there's so many different programming languages, and it's really difficult to devote time to one because you don't know which is the best one to choose. Obviously, I'm here making the case for SQL. And I also think that particularly for learning spatial SQL, the resources are really scarce. So you often have to learn a lot of SQL and then sort of work out how you can bring geospatial into that. And that's something we're trying to change at CARTO, is make a lot more resources available for people who have geospatial skills already to move into SQL. And here I am to prove them wrong. I want to debunk all these things today. So let's SQL, let's get going. So first of all, most GIS software that you're using will be SQL ready, and you might already be using it a bit, as Claire found out earlier in her Map Publisher workshop. I'm today going to be showing examples using CARTO Builder because CARTO pay for my rent, so I'm here to promote them. But there's lots of other software packages that you can use SQL in. I think a lot of people here will probably be using QGIS, and you can actually use the database manager in QGIS to run SQL queries, and you don't need to have a Postgres database to be able to do that. You can just use the project layers that are already in your project. So I think I'm right in saying I'll be able to share these slides later, so I won't run through every single one of these, but there's basically every GIS package that you're using, you'll be able to SQL in. And just an alert before we get started, the S in SQL doesn't stand for standard. There's actually quite a lot of different kinds of SQL, and most of them look exactly the same, but there will be some small discrepancies between them. So in this workshop, I'll be showing Google BigQuery SQL, but that will differ very slightly from things like PostGIS or Snowflake. There'll be some slight differences, but not very major. So first of all, what I want to do is to show you a really quick demo of a SQL a SQL query. So we'll start with the most basic of queries. So first of all, this is CARTO. If you don't have access to CARTO, here's my plug. Get yourself a free 2-week trial by going over to carto.com, and you can follow all of the examples in this workshop. But this is what CARTO looks like. There's a few different things you can explore through here. So I mentioned connections to data warehouses on the cloud. You can really easily do that here. We have our Data Observatory with our now 11,442 data sets from loads of different organizations. And then you have your Data Explorer, where you can explore the data that you've signed up to, whether it's data that you've loaded into CARTO yourself, so you can load in things like CSVs and shapefiles, or you can connect to data from our Data Observatory. And then finally, what we're all here to see really is maps. Absolutely love to map. So I'm going to open one I didn't really make earlier, BCS Demo A. And rather than make you watch me write out code, because I always spell so badly when people are watching me typing, I'm going to take one I've made earlier. So our very first query is going to be this one. So let's add a source from a custom query. And the way this works is you basically go select. Every SQL query starts with select, and then you select the fields that you want to select. So here I'm selecting geom, which is my geometry field, and crime type. And then I'm selecting them from this database. So my project is CartoDB marketing team. My data set, which is kind of like, you can think of it like a folder or a geodatabase if you're so inclined, is base data. And then my table is this Police UK Crime London 2021. So this is I can show you this in the Data Explorer just to give you a bit of a preview of what this looks like. Can I, yes, in here, base data, Police Crime London 2021. So you can see we've got 1.1 million rows and 265 megabytes of data here. So it's a pretty hefty data set. That would normally take quite a long time to load. But if I just click run here, we're on 1 second, and it's loaded. It will take a couple of seconds to load the whole data set. But we can see here, we've got our whole data set loaded in, and that's how quick it is to load in 1 million points. And that's how easy it is to just use SQL to load in a data set. So let me just, I could spend ages looking at that data set, it's so interesting, but let me head back to my slide pack. So what we just did there was perform the most basic type of SQL query, where we basically, all we did was we said we wanted every row in that data set, but we only wanted to select a couple of fields. So this is what a standard query looks like. You select your fields from the project, data set, and table. So here's an example. Claire was showing some natural earth data, which is something that we've actually, incidentally, another plug, got on our CARTO Data Observatory for sort of ease of use. So here we select all of our fields. So that's what that asterisk means. From the CARTO project, from the natural earth data, from this connection data set, which is my personal connection to the Data Observatory, and then populated places. So you can see here on the right, this is what it looks like on a map. And we've also got the table version of that below. So that's your most basic kind of query. And something really important to know when you're doing spatial SQL, and this doesn't apply to SQL if you're not using maps at all, but one of those field types has to be a geometry type. And what that basically is it will tell you what's the type of geometry. So point, polygon, multi-polygon, line. You're probably familiar with all the types, and then it will be a string of vertices, basically. So to be able to load that onto a map and to be able to do spatial analysis, you always need a geometry field. So what I'm going to do now is just run through some of the most basic types of ways that you can perform SQL queries, some of the sort of basic functionalities. So the first two that I'm going to show you here is orders and limits. So what these do is ordering is basically changes your data set. So the highest or lowest value is at the top and the reverse is at the bottom. So it orders it by whichever field you suggest. And then limit says that I only want to take the top however many, here we're choosing 5, the top 5 rows from that data set. So here, for example, we've got the top 10, that should say 5, top 5 biggest cities from the natural earth populated places database. So here you can see, as we've selected our columns, we've selected which is the table and project we want to take it from, and then we're ordering it by population, and then we're saying that's descending. So start with the biggest, end with the smallest, and then limit of 5. And then you can see on the right here, that's for the results of that. So we've got those top 5 cities that are most populated. We've got the map and we've got the table. I hope this is all making sense so far. It's kind of one of those things where it's quite hard to just explain this, but when you start doing it yourself, you'll really see how easy it is and see the benefits of it. So this is the part of SQL that I think a lot of you are probably doing already. It's the filtering part of SQL. This is where you take your standard query, and then at the end you add a where condition. So you say select fields from table, where, and then the condition. And the part that I think you're already doing already is basically what comes after where. So this is where you're saying if the name contains this, or if the value is over this. This is your sort of, if you use QGIS or ArcGIS, you might be doing a definition query, or you might be doing rule-based labeling or rule-based symbology. This is the sort of stuff that you're probably doing already. And doing it in SQL is you just tack it on at the end with a where statement. So here, with this example, we're taking all of our cities where the population is greater than 1 million. And there's a lot. And then this is something that isn't very exciting to illustrate, but it's one of the most useful tools that you can use with SQL. It's something called a common table expression. So this is where you basically give a query a nickname, an alias. So here we're using our populated places data set and giving it the cities alias. And you can't really see what's useful about it here, but it basically makes it loads easier to query multiple data sets at the same time, and it also makes your query much easier to run and quicker to run. So here's an example. So this is a join. So this is, if you're a GIS user, you might think of a spatial join or a table join. They're sort of done in the same way in SQL. So the standard syntax here is select fields from table, which you're already familiar with, and then we do a join to the join table, and then we say on condition. So that condition might be that you have two IDs that are matching in the two tables. So it might be a bus stop ID matches a bus stop ID, or you can do a spatial join. And we've actually done a big piece about this on the CARTO blog recently. So I won't go into this in too much detail, but just a really quick example of this here is we use our common table expressions again to create a cities table and a time zones table. And then we say select all of the fields from our cities table and select the time zone from our time zone table. And then we join the cities table to the time zone table on, and the condition here is the spatial condition. So we're saying where the time zone geometry, which is a polygon, contains the city. And what this does is attaches a column to our cities table that is the time zone value from the time zone polygon. I don't think I've ever had to explain a spatial join verbally before without sort of showing how it works. So I hope that made sense. But basically, I just wanted to illustrate that spatial joins in SQL are actually very straightforward. And this is the sort of thing that you can build in much bigger workflows. And it just is a really, really flexible way of doing this sort of analysis. So that's sort of some basic SQL. I wanted to show you a couple of examples of that in practice. If I have time, I think I'm fine for time. So back to my spreadsheet of demo queries. Let's get rid of that layer and let's load in this data set. So this is again a really simple query. We're just loading in the geometry and the label of this USA counties data set. So let's just run that. It shouldn't take too long. We're in the wrong part of the world to see it though. And still, so here we go. This is our USA counties data set. Let's just add on a stroke so you can see that. So it's a really massive data set, but as you can see with SQL, and this is a Google BigQuery Cloud Data Warehouse connection, that loads in really quickly. So I just wanted to illustrate again how easy these simple queries are to do. But let's hide that and add in another one, and let's start to build in a bit of complexity. So let's move on to this query, which is, let's zoom in a bit. Let me make that bigger so people can see on my screen. I never know how big people's screens are at home, so it's quite difficult to size these things. But this query is doing something a little bit different. So here we're selecting our geometry field, which is geom, from our USA counties. but we're performing a function on that geometry called st_union_ag. And this is basically, for GIS users, this is basically a dissolve. So this is basically saying where features are touching each other, dissolve them into one shape. And the purpose of doing this is we are taking we're basically creating an area of interest that is the New York City area. So we're saying we want all of the counties that have a GeoID which starts with 36, which is the New York State identifier. And we only want those that are part of the New York City, so these 5 boroughs. So let's see that in action. With these things, it's actually quite annoying because it's not enough time to go and make a cup of tea. That's normally one of my favorite things about doing spatial analysis is you start something running, make a cup of tea, come back and it'll finish. But here, you don't even have time to do that. I'm getting so many less breaks. So you can see here, that's loaded in. And now we've got one polygon that's our area of interest. Let's just turn that off and highlight this a bit more, so you can see that at home a bit more easily. So that's our area of interest. And then I think I've got one more on this section of the demo that I wanted to show you. And this is taking a data set from our spatial data catalog. So let me show you it on the spatial data catalog. This is one of my all-time favorite data sets. And I used to work with Claire, so she'll probably know that I say this about most data sets. But it really is very, very interesting. It's from a provider called Spatial AI. Here we go. And the data set is called geosocial segments. So if you've ever worked with a data set like Mosaic geosegmentation, it's a bit like that, but it's not based on credit card data. So this is basically a data set that assigns people from census spot groups, scores them against different characteristics based on their social media activity on things like Twitter and Meetup and Instagram. And there's 72 different profiles and everyone is scored against that. And the profiles are very wide ranging. So you've got things like engine enthusiasts. There are people who love cars, love trains. We've got people who are really into natural beauty, people who are animal advocates. So it's a really interesting, loads of our customers use it to help them understand where they should locate a store or where they should ship out their consumer packaged goods to, because it helps them understand how strong the market might be in certain places for it. So it's absolutely fascinating. I feel like I could spend all day playing with this data set. So as you can see, I'm subscribed to this, so I can just take it from here, but let me talk you through this query. Make it a bit bigger. So what we're doing here is we're taking the data set, the query that we ran before, our New York City area of interest, and creating an area of interest, AOI, with that. So we're creating that as a common table expression, or I call them subqueries, but apparently that's the wrong word. So we've got that as our polygon. So that's one sort of subquery. Next, what we're going to do is take the stats table. So in our data explorer, you'll see that most of our large data sets are split into 2 different tables. One is the geometry table and one is the data table. So just to make it smaller and easier to work with, we split them into 2 different tables. So we take our data table, which is this one, our behavioral geosocial segments, and we say we're only interested in the GeoID, which is what we'll use to create the geometry, and the index organized sports, so where people are super into like football and netball and basically people who are the exact opposite of me. So we're only interested in those columns, and then we're only interested in those columns that were recorded at this date, so the 22nd of April. And we're only interested in where that's a national comparison. So you can get 2 different scores for this, where scores which are compared against the sort of national average and scores which are compared against the county average. So now we have these 2 subqueries. We have our area of interest and we have our data table. Hope you're following. I can't see anyone's faces, so I'm assuming that's going well. So now we can move on to our final query where we bring all of that together. So first of all, this is actually a bit too big for me to see now what I've written. Hopefully if I make it a little smaller, you guys can see. So this is our final query down here. So we take our, where is it? This is our geometry table. If you remember, I said we always split our data observatory tables into 2, geometry and data. So this is our geometry table, which is USA blocks. And we want to take the geometry field from that. And then we join that to our statistics table. So we create a where the GeoID in the stats table, which is up here, and the geometry table are the same. Join those together. So we've got those two joined. And then the final thing we do is where we say where those census blocks are within a distance of 1,000 meters, we'll include those in the query. So what this will result in is we'll have a census block table with a field for an index of how much people like organized sports, those crazy people, and all of those should be within 1,000 meters of our area of interest. So let's just load that in. Add a source, custom query, add source, copy that in. Now, as you can see, this is about 2 gigabytes of data. So that is a huge amount of data to be querying because it's basically the whole of the United States, every county in the United States, it's every census block in the United States, and it's that huge 72 geospatial segments data set that we saw for that as well. So that is an awful lot of data that we're querying. You can see 4 seconds that loaded in. So let's just zoom out to our whole boroughs, and it will take a second to load. And here we go. So now if I just move into layer styling, I don't know why the default here is an orange stroke. I mean, who's ever used an orange stroke to outline their census blocks? So we can change the fill color to be by index for organized sports. Give that a couple of seconds. And that will stylize it. So that's done by quantiles, which is where an equal number of census block groups are in each color class. So we can see that the darker groups are areas where people are really, really into organized sports, and the lighter groups are where they're like not so interested. So I'd probably be living in this yellow area down here. So those are some examples of a slightly more complex SQL. Let's move back to presentation. How am I doing for time? Fine, absolutely fine for time. And now we're going to talk a bit about some more complex examples of SQL. So these are a few different things that you can use SQL for that maybe before this session, potentially you weren't aware that you could do. So these are just a few examples. So first of all, constructing. So that's where you're creating a new geometry. So you can do things like, there's a function called stMakeLine, which is, if you're an ArcGIS user, it's kind of the same function as xy2line. You can basically say, here are all my points, and I want to draw a line connecting each of these points. stJogPoint is where you can create a geometry field from 2 coordinates, so lat longs. And as I mentioned at the start, you always need to have a geometry field when you're running SQL queries that are spatial. So you can use these construction tools to be able to create those geometries, basically. stMakeEnvelope, so that's where you basically create a rectangular envelope around all your pre-existing geometries, and there are hundreds of these that you can explore. Transform, so this is where you have one geometry type and you want to turn it into another. So you can create buffers. I'm sure a lot of people here know what buffers are, but they're basically where you want to create a polygon that's, say, 200 meters around the outside of your area of interest or point or whatever that is. Intersection is where you have 2 geometries. So that might be a borough boundary and a rail line, and you want to create the geometry which is where those 2 overlap. Centroid, so you can really easily create centroid from polygons or from lines or from groups of multi-points. And SUnion Ag is one I showed earlier, which is where you can create dissolves. And again, hundreds of these to play with. So it really is limitless. And then finally, I've got my head blocking the next thing I was going to talk about, relates and joins. So this is where if you wanted to run sort of spatial joins, investigate spatial relationships, and you can use these spatial predicates to do that. So you can say, I want to calculate X based on whether these 2 features, this feature is contained by this feature, or if the 2 intersect, or if this feature is within this feature. There's, again, absolutely limitless, and I really advise taking a look on the CARTO blog, because we've recently done a piece all about this. So here's an example of a slightly more complex SQL query that takes some of those things into account. So here we create what we're trying to do is gather all of the countries that border the country of France. And this is all done using the natural earth dataset. So in the first common table expression, we select France. In the second common table expression, we select all the other countries in the world. And then in the third final query that brings those together, we select all of the fields from our countries table. And then we say, we'll just keep the features which touch France. So we say where we've got the geometry of France and the geometry of the countries, where those two touch, we'll keep them. And that results in that. And again, just to plug CARTO, and I'm doing this because I work for CARTO, but also I think their tools are absolutely incredible. I just wanted to plug a few of the things that the SQL tools that we produce in CARTO. So a lot of these tools that you've been seeing here, you'll be able to do in sort of base SQL or vanilla SQL, or whatever you want to call it. So when you're using QGIS or R or whatever it is you're using, those tools will be available as a default. At CARTO, we build SQL tools on top of those to basically try and make people's lives a bit easier. So one example is an area-based spatial join, which is, say you had a study area and you wanted to calculate the total number of people living in that study area, and you have your census data, but each output area doesn't exactly fall within that study area. So it's not easy to work out exactly how many people live within that area because the geographies just don't perfectly line up. I think what a lot of people, and what I personally would normally do for this, is run an intersect tool where you basically work out the proportion of each output area that falls within that study area and say that's the number of people who live there. So say if 50% of an output area falls within a study area, then 50% of that population get assigned to it. Which is something, if you're using normal GIS, you probably run an intersect and then do a few calculate variables and then maybe take it into Excel and do a bit more calculation and then bring it back in and then join again and then export that. So it's quite a long process. And in SQL, it's easier, but there's still quite a lot of steps to it in your code. So one of the tools that we've created is an enrichment tool, which is basically does all of that for you, but it's basically 4 lines of code, and they run super quickly. I've got an example to show you in a second. We've got multi and single variate hotspot analysis, so you can work out where are the sort of hotspots and cold spots in your data. Geographic spatial weighted regression. So this is a way of seeing how relationships between different variables change over space. Local outlier factor analysis. This is a really interesting one. This is where you can see how clustered points are and where there are outliers and sort of patterns within those. You can do routing and isochrone analysis with CARTO and SQL, which is absolutely amazing how fast it is and how easy it is to do and how much freedom SQL gives you and flexibility. And then we also produce some industry specific tools. So things like revenue predictors. So you can work out if you are going to put a store in this area, how much revenue you might expect to make. And we've done the same thing for electric vehicles. And then we've got some specific tools for across the wider retail industry and the logistics industry as well, because they tend to be most of our customers. And here's an example of one of those in action. I'll try and talk through it as clearly as I can. It's not as complex as I look, I promise. So the aim of this tool is to convert a geosegmentation data, which is at output area level. If you're not familiar with output area levels, sorry, I realize I've referenced them a lot. They're basically the smallest administrative geography that you get in the census. So loads of different data sets will be found at that level. Here we want to convert those output areas into a hexagonal grid. If anyone follows my blogs on CARTO, they'll know how much I love hexagons. I've written a blog post all about why hexagons are the vestigons. Please take a look at it. It's one of my favorite things I've ever written, but that's what we're doing here. We're wanting to convert those into hexagons. And what we're also doing as a part of this is we want to create a user group score. So we can see by the number 2 here, we have a variable called group, which are sort of string variables. So they're like 1A, 3D. We want to turn those into numeric variables, basically, to help us work out propensity to use a service. So it looks complex, but there's only really a few different steps to this. And it's all using our enrichment functions. So the first step is we're creating an area of interest. You've seen we've done this a few times. You can see this by the number 1 here. So in this case, we're taking our London boroughs and we're creating a buffer of 1,000 meters around them. So we've got a little bit of leeway there. The next thing we do is we take our output area geosegmentation data and we calculate our score, like our score for that, so our propensity to use the delivery service. Something to note here is there's 25,000 fields, so that's quite a lot. Not fields, sorry, 25,000 records. The third thing we do is once we've calculated that, we join that to the 25,000 output areas, the geometries of those. If you do this sort of work in GIS, you'll know that this can take a long time. And then the final thing we do is we perform that area-based intersection that I was talking about before to 19,000 hexagonal cells. So those are some big numbers, some big data that we're talking about here. But it only took 11 seconds to run, which is just incredible. That's the kind of thing where if I was using desktop GIS, it would probably take me a couple of hours. I might get something wrong and have to run it all again. And because I'm like the biggest typo person in the world. So it makes things so much faster. And then I think we're coming pretty much to the end. So I just wanted to show you one final demo that takes into account some of those things, and then I think we should have about 10 minutes at the end for questions. So this is one I made earlier, but it should look a bit familiar to you because our starting block here is our New York City area of interest. So I'll just walk through a sort of workflow for this, and the sort of aim of this map demo that I've created is for people to help understand where their potential customers are located. We're using, again, our crazy organized sports lovers data from Spatial AI that I showed you a bit earlier. So here we've got that loaded in on here. And you can see the lighter the color, so the more yellow it is, the more the greater propensity people have to love organized sports. Sorry, taking a sip of water. So the next thing we've done here is run one of those enrichment functions that I just showed you, this time to a data set called QuadBin, which is like H3 that I mentioned earlier, but it's a global square grid, basically. And you can see here, what we've done is we've taken our index for organized sports lovers, and we've multiplied that by the total population within each cell. So that gives us something called a TAM, or a total addressable market. I've just realized my head is floating over the widgets, so you can't see that. We want to see them. So the yellow areas is where the total addressable market is higher. So there are probably going to be more people there who are interested in a sports-related product. So you can see they're sort of around Manhattan in particular. Let's zoom into there. That's probably a bit of New York that we all quite know. So then the next function that we'll take from there, let me show you the SQL code. Open SQL editor. I won't talk through all of this code because we're at that point in the workshop where that will probably be overkill. But this is basically using a tool called GetIsOrdered, which you can see down here. GetIsOrdered is a hotspot tool. So we basically, in here, we plug in that data set that I just showed you, our QuadBin data set that has the total addressable market score. In here, it's the variable weighted pop. So we plug that in. So we're taking here is our GetIsOrdered calculation. So we plug in our quad key dataset and our weighted pop. And what that basically does is runs hotspot analysis. So it says around areas, the highest scoring GetIsOrdered scores are areas where you're finding loads of high values clustered together. So let's take a look at what that comes up with. So here we go. So the yellow areas are where the GetIsOrdered score is highest. So that's where you're getting loads of high values clustered together. So you can see that's sort of the Lower East Side, the Upper East Side, the Upper West Side, mostly Manhattan. We've got a few areas across the Bronx as well. So we can be really confident in saying these are areas where lots of people who are interested in organized sports are really strongly clustered. So if you wanted to sell a new sports drink in vending machines or open a new gym, these are your areas where you're going to be most confident of having a strong return on investment. If you wanted to take that to another level, what I've got here is some human mobility data from our Data Observatory, which basically, again, using that quad grid sort of mesh, tells us the number of pedestrians in each area. I think it's the average per hour across the day. So obviously the light pink areas are where there's more pedestrians, the dark pink areas are where there's fewer. No surprises to anyone that as you go to Manhattan, that's where you're finding more pedestrians. So what you might want to do after that is bring those things together. So what I've done here is I've just filtered my footfall data to areas, the 10% highest areas, which is if I just load this up, so you can see again, we've got our areas of interest, which is the New York area. We've got our statistics table, which is our footfall data. We join those together and then we say where staying, which is our footfall measure, is greater than 2,336, which is the 10% quantile band. We only want to see those, which gives us these light blue areas. And then what most users will probably be really interested in seeing is where those two things overlap. So where am I getting a really strong confidence that there's loads of people interested in organized sports, but there's also really high footfall. So there's going to be lots of people moving around and maybe passing by my store or potentially popping into my gym. And you can start to think of all of those factors together. So I think I've just got a final slide, potentially. And my head is again covering it. I don't know if you can see my floating head on Zoom, but I keep getting it in completely wrong place. So that's sort of it from me, but just to conclude, with Spatial SQL, your workflows would just be so much faster and so much easier. So you spend so much time waiting for data to load and actually get to do the fun thing like designing your map or running analysis, all the things that we all really love doing rather than watching a little spinning wheel. And it allows you to collaborate with other people across your team, across your company, across other companies, and it not just being a buzzword. And I also really want to say I've been at CARTO for about 6 months, and before that I really wasn't doing much SQL, and now I absolutely love it. I use it so much. I feel like I hate to use, I don't think I could ever call myself an expert in anything, but I feel like I have like really come on in leaps and bounds. So really, if I can do it, absolutely anyone can. Because I really don't have a very big coding background. I was very much a point and click GIS user. So hopefully I've inspired some of you to want to try your hand at Spatial SQL. So there are a few ways you can do this. Sorry, excuse me, just having a cough. I could have moved my head away from the microphone then to make that better for you, couldn't I? So you can head to carto.com and sign up for a free 2-week trial and try some of these things in CARTO. Or we'll share this slide pack and you can see how you can do that in whatever GIS software you use. And a few other resources if you want to move forward with this and do a bit more. I've got a blog over at helenmakesmaps.com. My most recent post was sort of this presentation, but in much more depth, much longer, many more examples that you can use and try. So do head over there to try that. And also just a shout out for the CARTO blog. I do probably about 80% of the posts on the CARTO blog, and they're all about sort of getting people excited about SQL, trying different things, lots of different industry focuses as well, so trying out really specific things for them. We've got a post coming up at the end of this week, I think, all about how you can create isolines with Spatial SQL. And then next week, we've got one all about how you can use SQL specifically for micromobility, so things like e-scooters. So if you're interested in transport, definitely check that out. And that's it. Thank you so much for listening. If you have any further questions, I think we've got a few minutes to talk now anyway, but if not, if you don't want to talk now, give me a follow at Helen Makes Maps on Twitter, or here's my email address at cartodb.com. Thank you so much for listening. I hope that was useful and or interesting.
Thank you, Helen. We've got a few questions on the chat, so I'll just repeat them. And I think everybody can unmute themselves now anyway, but I'll lead, and then if there's any follow-ups, they can join in. So Miss Alav has asked, thank you for the workshop. Question: how CARTO data catalog? How did CARTO data catalog harvest the sources? Can anyone contribute to it? And is there open data?
So I'll answer the second part of that first. So the whole reason we started the spatial data catalog was we found, and I'm sure like everyone on this call can vouch for this, is a lot of analysts are spending so much of their time sourcing data, basically looking for data, checking if it's correct, checking if it's accurate, can I trust the source, then formatting it into the format that they want, then loading it into their own data management platform. I think we estimate about 70% of most analyst time is spent doing that. And we really wanted to make that a lot easier for people. So we have basically two main types of data on our data catalog, public and premium. Public data is basically open data that we load onto our spatial data catalogue so that CARTO users can really easily access that. And that's things like natural earth, UK census data. There's some great geosegmentation data on there as well from CDRC. So there's loads of public data that can be accessed for free. And then there's sort of a sort of premium offering on there as well, where you can subscribe to data like MasterCard data, Vodafone data, lots of things like that. In terms of like vetting it, we absolutely do vet it, because that's the whole point of our spatial data catalog, is we want to be sure that it's really good data so that you guys don't have to spend time worrying about that. Hope that answers the question. Claire, you're on mute.
Typical. It had to happen at some point today, didn't it? It's not an online meeting if somebody's not on mute.
Absolutely.
Get used to. Sorry, there was a question before that as well that I nearly missed. How do you deal with edge effects when using the Getisord? Getis? Yeah.
Yeah, absolutely. So that was the hotspot tool that I showed you right at the end. That's a really good question. And the answer is actually quite simple. What we would normally do is, so say in that instance where we were looking at New York City and we were only really interested in New York City, we'd make sure that our source data extended out a certain amount. So in that example, I said I want to include all the data within New York City and 1,000 meters beyond that. So it's all about just making sure that you are pulling data from not just your study area, but a distance beyond that to make sure you take that into account.
Brilliant, thank you. And one more question from Simon Williams. Is there a way to easily display geometry coordinates in a human readable format from a query without having to convert with regex or case, for example?
I'm not sure what regex is, but yes, there is, absolutely. So you can use, off the top of my head, there are functions called st_x and st_y, and they extract the coordinates of your point. You can also extract vertices and do the same with those.
And he's also said nice blog on joy plots.
Thank you. You're all testing my knowledge of doing SQL, like, you know, doing like mental maths at school, like mental SQL.
Brilliant. Kirsty has said, looking forward to seeing the blog about micromobility, as I'm sure we all are. And everybody else has said thank you very much.
Great. No, thank you all for coming. I really enjoyed it. Do you know, my first ever public speaking experience, I think, was in 2018 with the British Cartographic Society that Claire kindly took me along to. So it's been an absolute pleasure to be back. So thank you all for listening. Probably see some of your names and faces at the conference tomorrow.